Alright guys, welcome back. So I made a new Bedini coil, much bigger than the one I have there. And I think it has like 10 layers, and it's got, I think this is 25 and 21 gauge wire. I also made an iron core that'll go in there. It's being stopped now because there's a edge of glue in there, but I can scrape that off. Yeah, so this is a good iron core. Sticks really well to the magnets. And it's much big. This, like I said, this coil is much bigger, much heavier too. See how that works out. I've got to solder the terminals on using my wire stripping tool. I love this thing. It works so good. Yeah, you put the wire in the hole, and those blades, see how they come together? They come together real softly just to strip the enamel. It works really, really well. Anyway, let me get this guy hooked up. Oh yeah, and I'm going to be using that new Bedini circuit that I told you guys about that I got super, super, super cheap. Compared to all the other prices on eBay, it was a fraction of the cost, and I was just curious. I mean, I don't know why I'm buying these things, but it worked really well, and I made a little PCB housing thing for it, whatever you want to call it. Anyway, yeah, so let me get the terminals on there, the green terminals, and some heat shrink tubing, scrape out that thing, and get it set up and see how it runs. Stay tuned. On a little quick side note, you can see up here all my excess wires, and I have them in bags, and I have them over here. I'm going to do something about that. So I 3D printed these wire hangers. And this particular one sits like this, and you just hang the wire, you just put the wires in there, and they just hang straight down. And then I have another set that you put like this, and you put the wires to it. But I think I'm just going to stick with the hanging straight down. And probably what I'll do is I'll probably put them over here, or take those papers down and put them on the edge there. I'll probably put it like right there so I have access to all my wires really quick, because I'm really tired of dealing with that nonsense, and it is nonsense. All right, back to the project. Stay tuned. Also, I did something a little bit different with this one. I made it have a solid bottom or top, whatever you like, and that'll go up against the rotor and the magnets so that I can get absolute minimum distance between, because that's really important in a Bedini circuit, and a setup like this is to get the smallest amount of distance. And I thought that would help. And it's only 3 millimeters thick, which I've decided is the new average for the thickness of my coils. It seems to be a really good size. 2 is a little bit too small, 4 is a little bit too big. Just like Goldilocks, it's just right. Anyway, yeah, so I thought that was unusual that I did that. And now I've just scraped out the insides so I can get the iron core in there, and I put it in upside down. That's all right. Let me grab a magnet. See if I can pull it out with the magnet. Oh, I can't do this one-handed. Anyway, stay tuned. And having that ferromagnetic core, iron core, will allow me to do things like test out different size magnets, putting on there when it's running the rotor to see how much of a difference, because it does make a difference. That's been shown many, many years ago. I forget who I first saw that with. I don't know if it was Zero Fossil Fuel or but one of the oldies but goodies back in the early days of YouTube when I first started. There was a whole bunch of us out there besides John Bedini, obviously, and Sky Collection making pulse motors. Anyway, let me get these glued down and then we'll get it hooked up. Stay tuned. All right, so I thought I was going to just jerry rig and hook this guy up, but I'm not going to. I want to make, and I'll probably 3D print it, a sliding mechanism so that I could slide the coil in and out. And I also want to figure out a way, and it'd be really simple. I just changed these out for flathead or, rounded flathead or something smaller than this so that I could get the, God, gotta love those VCR bearings. Thank God for people throwing out old VCRs. Those bearings are the best. That thing will spin for like 2 minutes. Just like that. No power. You can barely see it slowing down. Those bearings will spin forever. It helps too that that rotor puts on like a flywheel effect because the magnets are heavier on the end. Anyway, back to what I was talking about. I'm going to have to make some sort of sliding mechanism. I could make it out of plexiglass because I think I have enough. So let me take a look and see what I got. Or I'm going to 3D print a mechanism. Since this is a 3D printing pulse motor making channel, I should probably 3D print it. I don't know what's happening to my camera right now. I think I touched something. I'll have to look at that video, but I definitely touched something and I don't know what it did. I don't know if it blurred everything out. Anyway, stay tuned. All right, so I was able to grind these down, and unfortunately, only 2 of the sides have the concave portion on the magnet. The other ones don't, because only the north poles have the, I guess it's the concave for the screw head. So I was able to get these 2 down. I filed them all down the same size, but only the 2 north facing sides are in pretty good. Anyway, I'm printing out the housing that's going to sit here and hold the coil and have a sliding mechanism. And I was perusing YouTube, and of course, all of my recommended videos are, other Bedini motors and, other pulse motors and electronic stuff, which is fine. And then once in a while, a Newman motor pops up, and I go, oh, I remember that. And I built one of those. And mine is a behemoth, even has a lid, because the magnets, when I first did them, came flying out of this beast because I rushed to do it and I didn't secure it enough. But yeah, this thing comes apart. It's completely module. And I think, and I wound this one by hand and it came out beautifully. And I ran it using the typical Newman commutator type circuit. Then I also ran it using the JL94 circuit. And I think I'm going to play with this guy a little bit because I really like him. He came out really good, all 3D printed. Yeah, it's been a while. Those coils came out gorgeous too. I don't know why this is set up like that. I'm going to have to revisit this. Yeah, this guy is completely module. It comes off like that. Goes back on like that. and then even has a top for protection. Because like I said, when I first ran this puppy, so inside each of these ends on the north and south end, I don't know if you can see, there are there are 6 barrel magnets, 2 here, 2 here, and 2 here. What I'd like to do, and I think I even still have the STLs to change this out. Look at that. That is a powerful magnet. It's spinning that guy from way over here. Anyway, this is a gorgeous beast, and I think I'm going to play with it a little bit just to get it going, just to check it out again. Stay tuned. All right, so I printed out the base, or the coil holder. I had to make it kind of beefy because with this iron insert, it's going to really tug on that coil, especially that one because it's so big. And so I made the cutouts here and there. I'm going to drill a couple of holes to put inserts in. And in fact, what I may do is drill the holes just slightly undersized and use those brass inserts that I use for the 3D printers or 3D prints. Anyway, I got to glue all this stuff together. Came out nice. I like that design. This is the cubic infill design. And of course, this guy just sits right in there like this. And I cut out some holes there so I can wrap a strap around to keep it down. Anyway, let me get this thing glued up, and then we'll see what we shall see. Stay tuned. So here's the stand, which came out really nice. I actually beefed it up because there's a tremendous amount of pull on this coil. And I wasn't sure if I beefed it up enough, but apparently I have, because it has the iron core in there and it's not doing a lot of vibrating. Yeah, I have some felt underneath here, so this is like a hook to hold this, built in some, what do you call it, to grab this giant zip tie. I have it hooked to, I have it hooked to my super cap, and see what happens. 12.4 volts off of this Bedini circuit. Everything's nice and cool. Let's tune it a little bit, see what happens. That's speeding it up tremendously. Yeah, it's all looking pretty good. And again, this is just your basic Bedini test rig for testing different coils, maybe different rotors, and not even necessarily using the Bedini circuit. I did make these straps for it that would go over this, but I didn't put the holes in the right place. You can see the holes, not the holes, but the strap would come over like this and lock into those holes. And then, anyway, turns out I didn't need it. And we'll let it charge up this super cap. Let me get a meter on there and see where we're at. Unfortunately, I'm gonna have to find my stand. Let me put you guys on hold here. Stay tuned. Here we go. It's at 5 volts, climbing like 1/10 of a volt every second or so. You can see 18, 19. Let's see if I tune it up a little bit. No. No. No, right where I had it was good. Here we go. Let's let that run for a little while and see how long everything lasts. All right, stay tuned. So what I want to do, but I don't want to do one that's too big because I don't want to shock the system. I want to put a magnet on here because that does, I guess I can do this one. No, I don't want to use this one. Whoa. Let me use this one right here. I don't hear any real difference. A little bit of a difference, but not much. Maybe if I use a bigger magnet, but I don't want to. I don't, because the magnet I was going to use is this barrel magnet, and it's really strong. VCR bearings are freaking great. So this thing is holding up really well. I'm really surprised. I thought it would be wobbling all over the place. All right, stay tuned. Running off of the super cap bank. I don't know why it's not lighting up the oops. Anyway, running off the super cap bank. Let me pause it here. Stay tuned. Yeah, again, it's running off of the, I had to adjust it. It's running off of the super cap. Let's see what it's doing as far as draining it. Let's see what we got here. Down to 10 volts. Doing pretty good for 10 volts. I don't know where that noise is coming from. Oh, I see. The whole thing is sliding out. Let me take this off. Ouch! Oh no, it's in there. It's in there. I thought it was coming off. Come on. There we go. I don't know why it's not lighting up my bulb unless there's just simply not enough coming out of it. I've got everything hooked up correctly, I think. Yeah, the yellow, which goes to the green, which goes to the positive. Let me further examine that because I still have 10 volts left in this thing and it's going really good, so stay tuned. It's just a bad connection. So it's putting out some pretty good output for 10 volts on a super cap. I wish there was a way I could turn it down. Oh, actually I can. Oh, but if I turn it down too much on the pot, there it goes. Interesting. Must be getting down because it's starting to go a little bit dimmer. Still flying over here. This is a good coil. All right, guys. Thanks for watching. crazy flying now. Complete solid output. Gotta love it. Iron core. Everything is staying nice and cool. Whoa! Except for the, what do you call it? The diodes. They're quite hot. Lots of back EMF. And the diodes are okay. Interesting. Ciao. So this guy's next. I want to play with him some more. But I want to set him up the right way. The way it was meant to. Not using a circuit like the JL94 or a Bedini circuit, but setting it up with a commutator and the whole 9 yards. Stay tuned for that. Now it's humming the way it's supposed to be.